Hello everyone, welcome to Programming 4. I'm Dr. Mohammed Aoudi, and today we're going to explore a foundational topic, arrays in C#. Arrays are a must-know tool for handling collections of data, and understanding them deeply will make you a stronger, faster, and more efficient programmer. So let's get started with today's lecture. Here's what we'll cover in this session. First, we'll define what arrays are in C#. Then, we'll learn how to declare and create them properly. After that, we'll dig into array indices, bounds, and how to avoid common pitfalls. We'll master looping techniques, and finally, we'll explore the rich set of array methods available in C#. By the end, you'll be fully confident handling arrays professionally. An array is a special data structure that holds a fixed size sequential collection of elements of the same type. These elements are stored in contiguous memory locations. Each element can be accessed directly using its index, starting from 0. It's critical to know that arrays in C# are reference types. This means that when you pass an array to a method, you're passing the reference, not the actual data copy. Arrays can hold primitive types like integers and doubles, or even objects and strings. In C#, arrays are not just basic containers. They are actually objects of the system array class. This is extremely powerful. It means you get access to a whole toolbox of methods like searching, sorting, and iterating without having to implement these operations manually. Arrays are created using the new operator, and once created, their size is fixed. The general syntax for creating an array is simple. Type array identifier, nar new type size. For instance, newInt creates an integer array with 5 slots, all initialized by default. The size you specify can be a constant, a variable, or even a runtime expression. Once set, remember, the size of an array cannot change. Here's a concrete example. Int array numbers equal newInt 12. This creates an array capable of holding 12 integers. When you allocate memory with new, C# automatically initializes the elements with default values, 0 for integers, false for booleans, null for strings and objects. It's an important safety feature that avoids random garbage data in memory. Declaring and creating arrays, two-step method. Sometimes you may want to separate declaration and memory allocation. First, you declare the array variable like int array C, without assigning any memory yet. At this point, C is just a null reference. Later, you instantiate it with C equal newInt 12, which allocates memory and initializes the array. This flexibility can be useful when the size is only known at a later point. This slide shows what happens visually. After the first step, the array variable points to nothing. It's null. After instantiation, it points to a block of memory where each element is set to 0. Understanding this model helps you debug array issues later. You can declare an array without immediately giving it memory. For example, int array scores is valid. However, if you try to access it before allocating memory with new, you will get a null reference exception. Always be careful to allocate before use. Array indexing is straightforward but strict. The first element is always at index 0. If you try to access an element at an invalid index, like numbers 5 in a 5-element array, C# will immediately throw an index out of range exception. This runtime safety check prevents memory corruption. When you create an array of integers like newInt 10, C# automatically sets all the elements to 0. This default behavior ensures your program doesn't work with random garbage values from memory. In this example, we create an array of size 10, and a simple loop prints the index alongside the default value of each element, all zeros. Always remember, numeric types default to 0, booleans to false, and reference types to null. One cool thing about arrays is that their size can be dynamic. You can use an expression to specify it at runtime, like newInt n plus 5. Regardless of how you determine the size, C# always initializes the elements to their respective defaults. This behavior is crucial for reliable program execution and minimizes debugging headaches. Now, instead of manually assigning each element after creation, you can initialize arrays immediately with a list of values. This is called an array initializer. It automatically determines the array size based on the number of values you provide. This technique saves time and makes code cleaner and easier to understand. Using an array initializer example. Here's an example. Int array numbers equal 32, 27, 64, 18, 95, 14, 90, 70, 60, 37. We didn't specify the array's size. C# automatically detects that there are 10 elements. Also notice, when using this syntax, you don't need the new keyword unless you want to be very explicit. You can also combine approaches. For instance, you can specify a char array grade equal new char array A, B, C, D, F. Or you can let C# infer everything if the type is obvious. This flexibility allows you to pick the style that fits your project's coding standards. This diagram shows memory layout for initialized arrays. Each value gets its own index automatically, and you can immediately use or manipulate these elements later. For instance, an array 0 holds 100, grade 1 holds B, and so on. Now, looping is where arrays become really useful. The classic for loop is great when you need the element's index. It gives you full control. Alternatively, the for loop simplifies read-only traversals by automatically retrieving each element without dealing with indices. Always use the array's length property to determine how many elements it has. This protects you from accidentally going out of bounds. In our example, numbers.length returns 4, meaning valid indices are from 0 to 3. Easy, safe, and absolutely essential when looping. You can access an element by its index to retrieve its value, or assign a new value to that position. In fact, modifying array elements inside a loop is a common practice, like doubling each number or normalizing scores. Direct access and modification are what make arrays so efficient. C# makes sorting and searching extremely easy. Array.sort, numbers, arranges elements in ascending order automatically. Array.indexOf, numbers value, helps you find where a specific value is located. If the value isn't found, it returns -1, which is easy to handle. Arrays in C# aren't limited to a single dimension. You can create two-dimensional arrays, like grids or matrices, and even higher dimensions. Accessing elements uses two indices, one for the row, one for the column. Think of them like spreadsheets, row-column format. Accessing array elements is simple. You just use the correct index. For example, an array 0 equal 100 assigns the value 100 to the first element. Always remember that the last valid index is length -1. You can also use variables as array subscripts, not just constants. This allows for dynamic operations where the subscript depends on user input, program logic, or calculations. Loops and conditions can easily control the index values. When looping, always base your stopping condition on length. For int x equals 0, x less array.length, x++ is the gold standard. Going beyond length -1 will immediately throw an exception, something you want to avoid. Instead of hard-coding values, you can populate arrays algorithmically. For example, here we fill an array with even numbers, 2, 4, 6, and so on up to 20. This technique is useful in simulations, data generation, and tests.